Thank you for attending this presentation, which will focus on the AccuSizer A2000CMS. This is a liquid particle counter using the technique of single particle optical sizing, or SPOS, for contamination monitoring of particles in hydraulic fluids and other lubricating oils. The product we're talking about today focuses on particulate contamination in lubricating fluids, oils, gear oils, other lubricating oils. And these contaminants can accumulate over time. If you look over here, it could go from very clean oil to a very contaminated oil. And you can imagine these two oils would perform quite differently. This contamination accumulates with time. And with excessive contamination accumulation, this can lead to either degradation of performance or actual complete failures. So it's important to track the contamination levels. And the best way to track these contamination levels is with the use of a liquid particle counter. That is the technology we'll be discussing today. We'll be talking about the technology to make these measurements, the technology to automate the measurements, then also the various international standards which talk about how to apply this technique and how to interpret the data, such as ISO 4406. So we'll talk about using the liquid particle counter, and we'll talk about the standards for using this counter. And these standards can include the ISO standard for liquid particle counters, which is ISO 11500, hydraulic fluid power, using particle counters to make these kinds of measurements. What you see on the right is just part of the table of contents of the topics addressed in this particular standard, which include how do you clean the glassware, how do we do the calibration, how to make sure the instrument is ready for use, how might we deal with dilution, and also some other analysis procedures. And one useful table that I show here in the bottom left is a table just pointing out as you do replicate runs, as you do repeats, we have certain expectations of how close will the repeats be. And the maximum allowable difference does depend on the total number of counts in each channel. If you just have 2 counts in the given channel, you can imagine 2 to 0, that's a huge change, and therefore you can't have the same expectation for repeatability as if there were between 5,000 and 10,000 counts in that channel. So this sets the expectation. If we're going to set a specification on the repeatability, these expectations should be set upon the number of particles in given size channels. So that's a very useful table which I show here. The next ISO standard we'll talk about is ISO 11171, and this specifically addresses the calibration of the sensor for the liquid particle counters used for this test. For most other industries and most other applications, we calibrate these instruments using polystyrene latex standards, which are very narrow standards at very specific sizes. But in the contamination business, we typically use contaminants that are closer to real-world contaminants, and these contaminants are dispersed in a clean hydraulic fluid. What happens with these standards is there's a contaminant mixed in oil, and most people reference the primary standard, which is NIST SRM 2806. And NIST SRM 2806 has known contaminants in particles per ml at various size ranges. This standard is the primary standard. It's also a bit more expensive than many people are happy with, so there are also secondary reference standards available through various other laboratories, such as the one shown here. The table you see on the right is actually from the certificate of analysis from one of these secondary standards, showing at various size ranges the number of particles per ml. The calibration procedure therefore is you can go in and adjust the voltages to make sure that at given size ranges you match the number of particles per ml from the certificate of analysis. So the secondary reference standards are used more often than the primary standard. And the difference here, the people who create these secondary standards are using an instrument that was calibrated with the primary standard. But the majority of the customers who we know in the field will typically be using these secondary standards when doing field calibrations. The next standard we'll talk about is ISO 4406. ISO 4406, which you see over here, method for coding the level of contamination by solid particles. So this is really about data interpretation. Once we perform the measurement, what numbers are important and how are we going to express the contamination level of the sample we just measured? If we use the standard ISO 4406, what we will focus on is 3 size ranges, 4, 6, and 14 microns. We'll look at the contamination level in particles per ml at these 3 ranges. We'll make reference to the table here in 4406, And we'll say between these size ranges, what is the contamination level? And if we fall in, for instance, between 640 and 1300 particles per ml, would say that that is code number 17. So what we're going to do is do typically replicate measurements. Often we'll look at the average of the replicate measurements. And then we look at the code numbers at 4, 6, and 14 microns. We will describe the contamination level for that sample and the ISO code at those three size ranges, such as we see here where we'd say this is code 211917. What I show here in the lower left, and this are some suggestions which come from Wooten Consulting. These are machines or elements within machines. And it says, for this kind of element, what are the ISO target levels? So for instance, for a diesel engine, would like to see code 171613. So these are the numbers we'll focus on when using ISO 4406. But as I will mention later, there are other standards as well. And the reporting of this 4406 and other standards is automated in our software. The instrument used are liquid particle counters. And the instrument specified in these ISO standards is a light obscuration or light extinction particle counter. With basic light extinction, the particles pass through a light source. This generates a pulse height analyzer through the use of a calibration curve, then transform these pulse heights into a particle size. So we flow the liquid through the sensor, the particles generate pulses, and we convert that to particle size, and one at a time, we count and size these particles. This is a sensor based on only obscuration or extinction, where we're just looking in essentially at the shadow cast as the particle passes through the sensor. But the sensor we put in our system is actually more sophisticated. Here is the extinction detector or obscuration detector. In the AccuSizer LE400 sensor, we have also added a scattering detector. This allows us to measure down to smaller particle sizes. So we have these two detectors in our sensor. We take both of these pulses, sum them together, then go through the pulse height analyzer, or we also call that the counter, and with use of a calibration curve, one at a time we count and size these particles. So this is essentially a development beyond pure extinction, and this is using extinction and scattering, and this is a technique of single particle optical sizing, and this is a sensor we would use for these measurements. Now we can calibrate the sensor either using only the extinction sensor. Then we have the extinction sensor calibration, which you see above here on the left. And if we only use the extinction sensor, we kind of have the range of a little greater than 1 micron up to the 400 microns. If anyone does want to measure down to smaller sizes, you'll see down here in the lower left the summation calibration curve. And here we can measure down to 0.5 microns up to the same upper limit of 400 microns. So we have this overall dynamic range with this sensor of 0.5 to 400 microns. And in order for these measurements to be accurate, we can only have one particle at a time in the sensing zone, as you see here. But if we have more than one particle at a time passing through the sensing zone, then we'd take these two particles and count and size them as one larger particle. And that leads to what we call a coincidence error. In order to eliminate or at least minimize the coincidence error, we need to be aware of the concentration going through the sensor. And there's a concentration limit of the sensor of 9,000 particles per ml. If we exceed 9,000 particles per ml, then we have concern there may be a coincidence error associated with the result, and we want to avoid that. So it's just another physical aspect of the specification of the sensor we need to be aware of, and this may affect how we prepare the sample prior to measurement. Here is an image of the AccuSizer A2000CMS. What we see here are this system has been set up where there are two trays. We could have a single or dual tray system set up on what is essentially an auto sampler. On this auto sampler, you'll see the sensor up here. This is where the measurement is made. Over here, you'll see a syringe, and this syringe is going to do two functions. It's going to aspirate the sample up through the sensor, and then after the measurement, it will push it out to waste. So we have the sensor, we have the tray, this is the counter, which is the pulse height analyzer, and the computer and monitor running the system. So what's going to happen is there's a needle coming down from here, and this is going to come over and sample each of these tubes, take the measurement, push the sample to waste, and in between each measurement, it's going to actually clean the needle to make sure there is no cross-contamination. It is not unusual at all to actually have these samples pre-diluted. And the reason we may want to pre-dilute is two reasons. One reason is to assure the concentration is below the coincidence limit. The second reason we may dilute the sample is in order to reduce the viscosity to make sure that we can very efficiently aspirate the sample up through the sensor. So very often these are pre-diluted, and the sensor then will pass through all these samples in this tray. And we really can't even do triplicate on each tube with under 2 minutes for each tube. So it's a very quick, very efficient way to perform these measurements. And what I'm going to do at this point is switch over to show you a quick video of the system in operation. Here is a sample tray. What we'll see now, here's the tube coming over, and the tube, which is often straighter, reaches down in, and then the syringe pump will actually aspirate the sample up through the sensor. The sensor is mounted up here. It'll aspirate the sample up through the sensor for the measurement, and then before it moves on to the next sample, it'll move over to a cleaning port where it will clean the tube before moving on to the next sample. So that's how these measurements are made using the AccuSizer A2000CMS. The software platform that runs this system is our new AccuSizer software, which is relatively new, just introduced in the past year. It's a very improved, sleek, efficient system with up to 1,024 size channels, which is probably overkill for doing most contamination measurements. But it's very easy to use software. You can kind of dock the maintenance or other parts of it, so you can actually operate just a portion of the software that is important to you for the task at hand. It's very nice for both importing and exporting data. Importing data, as I show, might be useful when we're setting up the tray for the auto sampler. And exporting is useful in order to take the data, create the ISO 4406 codes, and export it either in reports or electronically. There's also a lot of functions that help manage the permissions of who can actually run the system, make changes, etc. The screen we see here is the screen where we could set up a protocol, which is essentially how we program the system to make a given measurement. What's the measurement volume we want to make? What's the flow rate through the sensor? What sizes do we want to work on? Are we going to do multiple measurements? Are we going to do replicates? Down here we also have the option of how we could do mixing of the sample prior to measurement. We can actually do this push-pull, where we actually pull the sample up and down in order to mix a sample, or we could also have an option with a newer system of using mechanical stirring. What kind of concentration limits are we worried about? So this is the way that we control the measurement for a given sample, and we could use this protocol for a given tube or for all of the tubes in the sample tray. So these are some of the options that we need to program in to make sure that we've optimized the measurement for the kind of sample in the data reporting required for the measurement that we're about to make. Other useful functions in the software includes a calibration mode. We certainly can come into the field and calibrate the sensors for customers, but some customers prefer to do this calibration themselves, and we're just showing the calibration mode screen where we can actually do calibration based on either samples and tubes or just manual measurements, so that we could import the C of A and then make it fairly easy to match the thresholds so that we can calibrate the sensor. And we do this probably every 6 months or annually depending on the protocol in a given customer's lab. So this is just showing the screen for the calibration mode. Now let's say we have a tray with 80 tubes in it. We can, through this particular screen where we look at the tray setup, set up the options for the measurements for each of these tubes. What is the sequence? Which protocol are we going to use? We can enter information, see this PDF. We could say in this case, these tubes have been diluted 10 to 1. And then it takes that value and includes it in the calculation so the actual concentration in particles per ml is accurate in the final report. So we could program the system using the software as you see here, or if we're doing larger trays, sometimes it's actually easier to enter the data into an Excel spreadsheet, and that's what we see up here. We could take an Excel spreadsheet, enter the information for each of the tubes, and then import this either as an Excel spreadsheet or CSV file, and then the system will take the data into here and feed that into the protocols in the system. So these are the different ways which we can program the tray prior to the measurement, and we could use the same protocol for each tube or use multiple protocols for different samples. The other screen you see in the middle here is just a maintenance screen where we can actually just make sure that things are operating properly, move the tube, move the syringe, make sure that we've initiated everything and aligned the auto sampler. So this is just some screens showing how we set up the system prior to the measurement. We then go out and perform all these measurements automatically, and we want to report the data. The reports you see here our reports using the format from ISO 4406. And in ISO 4406, remember we have these 3 classification codes. Here you see a report for a single sample, and here you see we're looking at the reports from replicates. And it's not unusual to do 3 replicates, check the repeatability, and then report on the classification code for the average of the multiple runs. We can also report this information as an Excel spreadsheet or report for all of the data in a given tray. So if we're going to have a high throughput situation, maybe we're running 200 samples per day through the lab, sometimes we just want spreadsheets or single pages, which gives us all of the data for all of the tubes. And this is showing how we can also accumulate the data, present it in written reports, electronic reports, or we could export this data to the laboratory LIMS system. So that's data reporting. Let's look at just a few of the technical specifications for the system. If we use the extinction only calibration, the dynamic range is 1 to 400 microns. We can measure down to smaller size ranges for other applications, down to 0.5 microns if we use the summation calibration. There are many more channels of size information than required for the applications we're discussing today, but we can choose, do we want to look at the data in anything from 1024 down to 64 or fewer size channels. When we talk about the auto sampler, we also talk about the trays, and we can have 1 or 2 trays, and we have different racks available depending on the throughput, and also just what size tubes perhaps are already used in a laboratory, or what size tubes are appropriate for a given kind of application. And I showed some of the features of the software, which includes how we control the measurement, the auto sampler, how we define the tray and what's available, what kind of samples, the number of samples in the tray, and how we're going to perform those measurements, and we define how we're going to do the reporting. So that is a quick overview of our AccuSizer A2000CMS system, which is certainly the most advanced instrument now available for these contamination applications. We have a very sophisticated but easy to use software interface. The auto sampling platform is fairly easy to input the information of how we want to do the samples, and our report generation makes it easy to interpret the results, either following the guidelines in ISO 4406 or also other older contamination standards such as NAS 1638, NAVAIR, or others. And since these reports can be customized, if customers actually have their own specific requirements, they can use HTML code to customize the reporting to their specific requirements. So this is a fast, easy way to just burn through a lot of samples, up to 200 samples per day. Very easy to operate, but certainly we, of course, come on site to make sure the people who are using this tool understand how to use it and help them use it in their application to optimize their results. The last thing I'm just going to say, additional information is available on our website, of course, at pssnicomp.com. And if you go here and you click on documents, you can download other documents, including, for instance, I think I pulled up the application note for ISO 4406, which is a document you could download, or the flyer on the AccuSizer A2000CMS to get more detailed information on how the system operates. So I want to thank everyone for their attention today. I hope this is useful. Please get in touch with us if you see this system as something that could be helpful for your laboratory.